Regents exam, Algebra 1, August 2016, problem number 15. Which function has a constant rate of change equal to -3? In this problem, we are asked to determine which of the four functions has a constant rate of change equal to -3. In other words, we need to figure out which option has a consistent slope of -3. Notice that each option represents a function in a distinct way. To figure out this problem, we can systematically determine the slope for each of the given functions. Let's start with option 1. Here, we have a function represented in tabular form. Each row represents an ordered pair, or point, of the function. We can determine the rate of change, or slope, of the function by calculating the rise over the run, or the change in y over the change in x. We do this by choosing 2 points and subtracting the y coordinates, and dividing the result with the difference of the point's x coordinates. We need to make sure that this slope is consistent, no matter which 2 points we decide to use for our calculation. Using the first 2 points, we compute the slope, which ends up being equal to 3/1, which simplifies to +3. Since the slope is not equal to -3, we do not need to check the rest of the points for this option, since the slopes have to be consistent regardless of the points chosen. So we can eliminate this option and move along to the next one. For option 2, we once again have a function represented as a set of ordered pairs or points. Similar to option 1, we want to compute the slope between 2 points and check to see if it's equal to -3. Using the first 2 points, we compute the slope, which simplifies to -3. It seems that we found our answer, but we need to make sure that this slope is consistent, regardless of which 2 points we choose. So let's find the slope between 2 other points, in this case, the second and third point. Computing the slope, we see that we obtain a totally different slope. Since this slope is not equal to -3, we do not need to bother checking the rest of the points. We can conclude that this option is not our answer. Moving along to option 3, we see that this function is represented in graphical form. So we can determine the slope by calculating the rise over run between 2 points. In this case, we can use the y-intercept, which is equal to 0,3, and the point 1, 1. Computing the slope, we obtain -2, which is not equal to -3, so we conclude that this option is not our answer. From the process of elimination, we know that option 4 should be our answer, but let's make some calculations just to make sure. The function from option 4 is an equation of a line, so we can determine the slope by rewriting the equation in slope-intercept form. So we go ahead and divide the function by 2. We then simplify both sides of the equation. Doing that, we obtain the following expression. Writing the equation in slope-intercept form allows us to clearly see that the slope of this linear equation is equal to -3, so option 4 is our answer.